inside a container apt get, because a container is Ubuntu. Install net tools. I'm installing inside a container and IPA. It was not there, so I installed it. IP if config. Yeah. So this is the container. This is the IP address of my container. Understood, guys? Look at this. So here I showed you. Understand that. Here I showed you my process table of host machine. Here I showed you inside a container. Here I showed you my process of the host machine, mount for the host machine. Here I showed you container. Here I showed you the IP address of my host machine. Here I showed you of the container. Separate resources. This container has it. Are you able to understand that or not, guys? Hello? Hello, I'm audible? Hello?
Yeah, Rajesh. Yeah, you're audible.
Yeah. So guys, what is the container life cycle? So nothing great about it. VM's life cycle, what you do? Create containers, start containers. Now I'm starting teaching you, okay? Stop containers. After that, start it once again. After that, if you restart it, you can pause this container and then you can unpause this container. Then you can kill the container and you can remove the container. These are the life cycles. So can I do that? So this time I'll do with the Apache image because that I can access through the network. Ubuntu containers I cannot access through the HTTP or something. What to do? Docker images. Do you have images? No. Which image you want? I want HTTPD. I'll search for it. HTTP Apache image. Here. Official image is here. How do I pull it? Docker pull HTTPD. Okay, so you are pulling that image. So you are pulling that image. Done, guys. Now, how many images I'm having in my local? Two images, Ubuntu and HTTPD. How do I see how many containers I'm having? One, which I created last time. How many I see how containers running, executed, and created? PS-A, all. Clear the screen. What you want to do? I want to create a container. How do you do that? Docker create HTTPD from image. Created a container. Docker PS. Not running. PS-A. You see that created. This container ID. So every container you create is you get a unique 40 character SHA values. This is the few shortcuts from container is running, will run with this. He's running with this 6 seconds ago. Name of the containers is random. So you want to influence the name, you can create one more container, hyphen name, Raj1. And here you see I created one more container, Raj1 here. So guys, I created a container. Can we start the container? Yes, let me start the container. So I'm going to start the container Raj1. So you can use the start command and container ID. You can use the name also that is unique to the host machine. So here you can use this one. And you see that now it's up. Can we start this also? So start and this. So here these two containers are running, three containers are running. Can we stop this container? Docker stop. When you stop the container, it will be in an exit state. You see here, exited. So can we start this container again? So Docker start and this container. And now it's up. You see here. So here you start, stop, start again. Can we restart? This is running from last 6 minutes. So Docker, restart the container ID, and I restarted it. Now, and here you see we started it. So can we pause the container? Can we pause the container? So how do we pause it? It's running from 53 seconds. Docker pause and enter. See here, it's paused here. Can we unpause it? Yes, unpause it. And here this is unpaused. It's running. Can we kill them? So Docker kill and this container I'm killing. Killing will also execute the container. And can I remove it finally? You can remove only the exited container or created container. Running container, you cannot do that. So remove it and it's gone. So this is the life cycle which you follow. It was so easy to do that. Any questions so far, all of you?
Raj, we
All
got
of
one
you?
question. Uh,
Yeah.
when you ran the command and it downloaded the Docker image, how does it know where to go? Has it been programmed in the Docker engine itself that it has to
Yes,
go
yes,
to
yes.
Docker?
Yes. This is a registry. This is the address of hub actually, hub.docker. It's a built-in address actually. You can change the address also, or if you give the full path, http dot dot dot, it will go to the other registry also.
Okay, thanks.
More questions, guys? So, guys, you
So,
saw that. Yeah, tell me.
so yeah, Raz, so Docker run and Docker pool, right? So both are different, right?
Run, I have not explained you. I'll just come back in 2 seconds.
Okay.
Any other questions?
Okay.
So I showed you the demo of this one only.
So is it different like Docker Swarm, Rajesh?
Docker Swarm is equivalent to Kubernetes, which I'll teach you after 1 month and so more than that, I guess.
Okay. So the Docker, these things, right? So how can we real time we can useful in real time, I mean, in production
Docker
wise.
Docker, if you want container, you want to run in the production, you'll have to learn the Kubernetes. But Docker use cases is nothing. So you want to run your laptop some application, and Docker and the one which I run the command, you can run it. Simple. Lakhs of images are available for you. Just download it and run it. Simple.
How many such
Okay.
containers can be run on machine or it's bound to, how do you know that number?
Okay. I can give you this answer straightforward, but I want you to think container is nothing but one process running in your system with their own resources. It's like a user. See, I'll put it in a more simplistic way. You and me, see, my name is Rajesh Kumar here. I am very unfortunate actually. Why? This Rajesh Kumar is unfortunate because Rajesh Kumar and you log into this laptop, you both will see, we all will see same C drive, same network, and same pit tray. But you know what? Docker create a user. I repeat, Docker create a user which have their own resources. So these users are lucky users. So remember that. Don't treat containers separately from you. You are a user, so container are also user. The only difference is the container users will have their own resources like mount, nnet, and ps. We will not have it. So your question was, how many containers I can run? So I think you know the answer. How many software, how many application, how many process you can run depends on that how much that application consume the CPU and RAM and the limitation of physical machines. Correct now?
Yeah, understood. Thanks.
Yeah. So this is the something which we have. So now guys, I'm going to teach you something more. So there is one command you might see everywhere, and this command is docker run. So what is this command? And in fact, I run it also. So every time when you say docker run, what does that mean? So docker run is a shortcut for commands like pull. So when you run the docker command, pull will happen, plus create will happen, plus start will happen, and then attach will happen. Okay, so now pull, create, and start I showed you manually just now. I hope you don't get confused. So it always create a new container. You run the image, any image 10 times, it will create a 10 containers because run has a create. Correct now? So pull, create, and start. Just now I showed you the demo. So I am assuming that you know that. Correct? All of you?
Yeah.
But what is attach? So guys, right now, who are you? So I am Bash. I am a Bash. Do you want to become this one, which is a PID one of the container? Do you want to become that one? This is the one which you see command is a PID one. Okay, so PID one of the container. What is a PID one? So if you look at the PS-EF, look at this. This is the PID one of your system. Your please hear me out. I may not be able to write this one. This is the fundamental of compute. Your physical server is running because of PID1. Your virtual servers, the one which I'm showing you now, virtual servers, is running off PID1. Your container is also running because of PID1. In the physical server and virtual server, PID1 is your system D. And in container, the PID1 can be anything like ls, some shell script, some Python, Java, Perl, Bash, anything it can be. So here what I was trying to tell you, attach will attach to the PID1 of the container. You want to see that? Let me show you here. So docker ps, this is the container, docker attach. I'm attaching directly, I'm using that command, okay? And here, where are you? Do you think the system got stuck? No. Actually, you are right now. Earlier you were bash. Now you become a HTTP foreground. I want to prove it. So open up a duplicate sessions here, and username is root Rajesh123 and docker ps container running. Let's get the IP address of it. How do I get it? Inspect command, okay? Inspect command, and you'll get the IP address. This is the IP address, and I'll create a request to the HTTP server, web server. And you see here, one request, two requests, three background also, you see that. So it's not stuck. Actually, you become HTTP. Now HTTP foreground is PID1. So the moment you kill this, remember that the moment you kill the HTTP foreground, PID1 got killed, PID1 got killed, container got killed. If you want to shut down your system, I need to kill this PID1 of your system also. So it's very simple concept. Please remember that. So docker ps-ef, if you want to shut it down, this PID1, if you shut it down, this one, your system will shut it down. So same in container also, PID1 is gone, container will get into the exit state. You see that here. It's not running anymore. So what I'm trying to say, PID1 is running your container. As long as the PID1 is running, container is running. PID1 is exited, container also will get exited.
Thanks for watching. Want to study further? Join our training programs today.